Hello and welcome to our talk about the industry track paper, the SPECpowerNext benchmark suite, its implementation and new workloads from a developer's perspective. Why developing a new standard benchmark? First, they drive innovation among competitors. They also create a competitive and fair playing field among them. And energy efficiency for servers has become a major issue. Data centers consumed about 263 terawatt-hours in 2020, and it's estimated that its energy consumption will rise to about 1,137 terawatt-hours until the year 2030. One major milestone in standard benchmarks is the SPECpower Ssj2000n. It has 728 peer-reviewed publicly available results and helped increase the energy efficiency by 19 times on average. And as we can see on the figure on the right, it helped increase the energy efficiency of single CPU servers and single node servers by 113 times. To increase energy efficiency even further, a new version of SPECpower is currently developed. It has new modern workloads, a wiki and an auxiliary processing accelerator, short APA, a new basis, Chauffeur WDK, a standardized way for collecting hardware information. And we will give a short overview of the SPECpower Ssj2000n and its workload, the SSJ workload, a short description of the benefits of using Chauffeur WDK for the development, a description of the new workloads, and some preliminary results for the wiki workload of the current version that is currently developed. We will also give a quick overview of how Redfish standardizes collecting server hardware information. First, we take a look at the SPECpower Ssj2000n Benchmark. It consists of two systems, the controller and the system under test. The system under test executes the workload, the SJ workload, and the controller runs the PT-daemon interface, which manages and collects data from the temperature sensor and power analyzers. It also runs the control and collect system, which calculates the score on the measured throughput and the power consumption from the power analyzers. The hardware information from the system under test is collected with specialized shell scripts. All components of the SPECpower Ssj2000n benchmark had to be self-implemented. In comparison, the SPECpowerNext benchmark does not implement everything itself. It uses the tool Chauffeur WDK to take care of most of the control and reporting system. Chauffeur WDK has been built to stress multiple system components by sequentially execution of what is called workloads, which are a further division of a workload. So the workloads are grouped together in a workload. We can see this on the right, on the lower figure for the SPECpowerNext, where the wiki workload has three distinct workloads, which are called transformation, natural language processing, and security. Chauffeur WDK allows easily development of multiple synthetic workloads for a larger variety. It can measure at different load levels and has cross-platform support. SPECpowerNext also adds Redfish, which is a standardized manner over a RESTful API to collect hardware information from the system under test. It also comes with a graphical user interface for the user to easily change settings in the benchmark and use a benchmark. As already mentioned, SPECpowerNext comes with two new workloads, the wiki workload and the APA workload. Each of the workloads is then further divided into worklets. In case of the wiki workload, it's three worklets, the transformation, NLP, and security workload, each taking different tasks that need to be processed. For example, the transformation workload uses compression, decompression, data serialization, and JSON parsing. The APA workload, on the other hand, has 10 different workloads, mainly arithmetic computations, and also data copying, fast Fourier transformation. All workloads have two implementations as a CUDA and OpenCL kernels to run on a multitude of different devices. And the general process of running an APA workload is the following. First, the test data needs to be initialized for processing on the compute device. Then the buffers on the compute device are prepared and the test data transferred to it. After the computation has been finished, the process data is read from the computation device and Chauffeur-WTK validates the test data in the background. To give you an impression how the new workloads for the SPECpowerNext work, we made some preliminary measurements. Please keep in mind that these measurements have been made with a development version and do not necessarily represent the final version of the benchmark. You can see two figures. The x-axis represents the time. In the first figure, the y-axis is CPU utilization, and in the second one, it's available memory on the system under test. In the first figure for the CPU utilization, we can see all 4 load levels clearly, but with slight variations across different workloads. This is to be expected, as not all load levels correspond to a certain CPU utilization. But we can also see that SPECpowerNext can stress the CPU to capacity. The memory, on the other hand, does not show different load levels. This is the case as the wiki workload is a synthetic workload that is not explicitly tuned to stress memory consumption, but is a mixed workload to stress different components of the server. But we can see that all workloads stress the memory and utilize most of the memory, with NLP being the one stressing the memory the most. If we take a look at the total file operations in the upper figure and the read and write file operations in the lower figure, we can see that the wiki workload also stresses I/O components compared to the Ssj workload. For the transformation workload, we can also see clearly that there are the 4 load levels present, while for the NLP and security workload, they are less pronounced. We can also see in the second figure on this slide that almost all file operations are file read operations, while file write operations barely occur at all. When we take a look at the amount of data read or written to I/O, we can see that the amount of data written is low, with peaks just about 6 megabytes per second at the end of each workload. As can be seen each of these measurement windows, around 800, 5200, and at the end of the figure. Contrary to file operations, most data is written instead of read. This needs further investigation to find the source of this behavior, and we plan to improve this behavior in the final version of SPECpowerNext, keeping in mind that these are preliminary measurements made with a development version. In conclusion, standard benchmarks drive innovation and create a competitive and fair playing field, while at the same time energy efficiency for servers is still a major issue. And to continue their success in increasing energy efficiency, a new version of SPECpower Ssj2000n is currently under development called the SPECpowerNext. It is based on Chauffeur-WTK to allow a quick development, and it comes with standardized collection of server hardware information through a RESTful API. It also comes with 2 new workloads, the wiki and APA workload, stressing multiple server components. Thank you for your attention.